Good evening and welcome to this evening's webinar, IB Sequences and Series, Sine and Cosine Rules, hosted by Texas Instruments Australia. My name is Rodney Anderson and I will be your host for the webinar tonight. As you're aware, Operating System 4.2 has been released, so you can upgrade your handhelds and all your computer software. So a lot of great features in the new version, so if you get a chance to, please upgrade. Now the webinar is being recorded and will be available to view at a later date via on-demand along with the panelist documents. They have the TNS files and other documents. It is recommended that you view the webinar and not try the activities as you watch live, as you can pause, fast forward and rewind the recorded webinar at a later date. Now, if you wish to ask questions during the webinar, what you can do is actually move your cursor up to the top of the screen and down the drop of menu you can select chat, and then you can actually select the host, which is myself, and send me a question. I haven't actually started the PowerPoint there, just show you the screens. Then, once you've actually done that, send it to me, and then I'll ask the panelists to answer some questions, if you've got some questions. Now, you can listen to the webinar by computer. You can also phone in, so you've got the toll-free number there, and also your meeting number, and listen to the instructions and press hash after entering the meeting number. After the webinar, the feedback is very important to Texas Instruments Australia. Please take the time to answer the survey. And also, during the feedback, you'll see a little icon to select, and you can actually select that icon to receive email newsletters of upcoming events and webinars. And you get an email within a day or two regarding the webinar, and it actually contains your link to actually print your certificate of attendance, which is good for your professional development hours. And our two panelists tonight, Peter Flynn. Hello, Peter. And hello. He's there. And our first panelist for the evening is Sandi Donatus, and it's her first webinar, and she's teaching at Wesley College, and as you see there, very passionate about mathematics, and she's also an examiner for IB studies. So I'd like to welcome Sandi, and away you go, Sandi, for your first session.
Thank you. Hello everyone. I'm going to be talking to you on sequences and series using the non-CAS calculator, which makes it a little bit trickier. We're going to be talking about generating arithmetic and geometric progressions, sequence and sum operations, end-solve, simultaneous equations, solutions of polynomials, and graphing for solutions.
So we're just waiting for your screen to share.
So I have to do that again?
Yes, so if you click on the share, that's all right. That's no worries.
I did.
Yeah, it's all right. Sometimes I just need to click on that and then it'll come up after a few seconds. So we're just seeing that there. We're heading there. We're getting there, just about there. And you're good to go, Sandi.
There we go. So everyone's heard what I've been doing.
Mm-hmm.
And yep, so the second bit, easy to calculate a sequence. I'm just going to use basic sequences so that you can see what we're doing. The first one is arithmetic with u equals 1 and d equals 2. The second one is geometric with u equals 1 and r equals 2. So it's easy to calculate a sequence. So the arithmetic one, I would just type in 1, enter, and then I could just type in plus 2, enter, and it just keeps putting it down all the time. Or, alternatively, I could do the geometric one, so 1, enter, and then times 2, and keep going down, and you get it. There is a sequence function on the calculator. Sometimes it's harder to find, so sometimes it's better just to type in the word sequence, or seq, with a bracket. And the first sequence I had, u equaled 1, and then I just type in n minus 1 times, don't forget the times after the bracket when you're in trouble, 2, enter. Oh, no, I know what I did. Nerves have got me, sorry everyone. I go back, so you've got to let the calculator know that your variable is n, and say I want the numbers the terms 1 to 10. Enter, and it will give me the sequence there. You can also find the sum of that sequence rather than using a sum formula. You can just type in the word sum, go from italic to normal, and then just scroll up and bring down that formula, enter, and it gives you the sum of the first 10 sequences, first 10 terms, which is terrific. You can also use the same with geometric ones. So you type in sequence and you type, not sequence, 1 times, because u equals 1. I'm not going to bother with that, but I'm going to use the fraction line there. 2 n minus 1, n minus 1, move it down, and it's over. That's it. Oh, sorry, I'm on the wrong one. So 2 to the n, to the n minus 1, and then move it down, comma n, and I want to get, again, numbers 1 through to 10. And there's my sequence again. You can do the sum of that as well. Sometimes we are asked to find, I've jumped a page. Oh, I'm missing some. Sometimes we need to find the nth term. It's very much easier just to use a graphing tool. So the nth term, for example, is, sorry, my calculator has now, I've lost the slide somehow. So I'll insert a graph, and I'll put the rule in that I've got for the arithmetic sequence, 1 plus n minus 1 times 2. This is not, I didn't do this on my...
That's okay. You can basically just get a new slide and new features through your application there.
But I didn't set this up. So we might move on to the next slide. Oh, here we go. So the nth term, here it is. Try graphing to see all the values. Remember to use x rather than n. Don't use n in your tab. And you get that, and then you can go Control T. So if you press Control and then the button T, you get a table up. So you can see the first term is 1, the second term is 2, and sometimes that's easy to solve if you have to find the 17th term, or you have to find what term number is 33. You can just go across and say, well, that's term number 17. Alternatively, you can do the same thing for the geometric sum. Don't forget to use x rather than n. You can graph it then and press Control T, and again you'll get the table and you'll find the sum. So if you know that the sum is 1023, you know that that's the 10th term. What about infinite geometric sums? Well, you can do those too. We don't necessarily even need to use the infinite geometric formula. We can see that we've got the sum formula there, and I've used x again. There's my graph. I can press Control T to get the table up, and I can see that it is getting close and close and close to 4. So the infinite sum of this particular one would be 4. So sometimes that's a lot easier than using the formula yourself. Using nsolve, find the sum of the series. So we've got u equals -3, d equals 4. What is n if the last term is 81? So with this one, I can use nsolve, which I'll get to my next screen. Nsolve is on the menu, algebra, and numerical solve, or you could just type in the word nsolve with a bracket. So -3 plus bracket n minus 1 bracket times 4 equals 81. So it's got to be an equation, and you want to solve that for n, and it'll give you the answer there. So that's quite easy using nsolve. With a geometric progression, you can still use NSolve as well. NSolve, the only problem is it will only give you one answer. So if you're using a quadratic or anything that's higher than a linear, it will only give you one answer. But with a geometric, you can use NSolve. So the third term is 8 and R is 4. Find the 10th term. I'm going to copy that. So Control-C will copy those things. Get onto here and I can type the words NSolve, or I can go to menu and get it. I'll paste it, and I need to solve that for U because I want to find the first term. So U is 0.5. Not always this straightforward. Sometimes you have to find two variables. So if the third term is 8 and the 8th term is negative 17 of an arithmetic progression, you need to find U and D. Since we're missing two variables, we use simultaneous equations, which is a great function on the non-CAS. So you have to go to Menu, Algebra, and Solve System of Linear Equations. There's two equations. I'm going to change my variables, though, to U and D. Okay, so it brings up something like that. Now, if you go back to the original question, the third term is 8 and the 8th term is negative 17. So the third term is 8, so I go U, the first one is U plus D, 2 times D equals 8. And then you can tab down, and that sends you to the next one, U plus 7D. Oops, I didn't do times. Sometimes you do, sometimes you don't. Equals negative 17, and press enter, and it will give you the answer for those. So you have the answers for U and D. As I said before, sometimes finding the sum of arithmetic progressions, often the equation isn't linear, so we can't use NSolve effectively. It only gives you one answer. A quicker way to use is polyroots. Now, polyroots can be tricky because you have to, you cannot have any brackets in it. It has to just be a straight polynomial. So we'll look at this question. Find the number of terms in an arithmetic progression where U equals 28 and D equals 6, and the sum is 5800. So I've set up these equations already. You've got that equation there. You can graph that from here or use tables depending on the question, but sometimes the question does ask you to show the quadratic, so you are going to have to multiply that out. Now that I've got that, I can use polyroots to solve that. As I said before though, polyroots has to be an expression. So polyroots you'll find in menu 3, oh hang on. How did I do that? Menu 3 and solve, polynomial tools 3, go down to 2, and that will give you polyroots. So it was menu 3, 3, 2. Now the equation that I had, notice that it already equals 5800. I have to have that equation equaling 0. So I would just type in the equation equaling 0, so 28n plus 3n squared over here minus 3, and I don't mind that I haven't subtracted anything. I teach studies and they sometimes get that wrong, so I'll just leave it like that, but there are no brackets. I'm solving that for n, and it will give me 2 solutions. Now I think I've typed in that wrong because I should have got integers, and I did rig this so I would get integers. What did 3n? That's what I did. Yeah. I know what I did. So go up there because you can only get integers as an answer. So that should be n there. There we go. Now I've got 2 answers. The question was asking me, if I go back, find the value of the term number. So obviously the term number can't be negative 1.5 over 3, so the answer is 40 in that one. So polyroots is really good, but it is an expression and it has to already equal 0. Another problem that you might have for geo and geosequences, you often need algebraic skills that aren't there. Teaching studies, I know that they don't. So a situation like this, k minus 1, 2k, and 21 minus k are consecutive terms of a geometric sequence. Find k. So to do that, I would need a fraction and fill that up. So 2k on the top, and on the bottom is k minus 1, because the second term divided by the third term. Move that over, equals, and then put in another fraction. So that's what I'm looking for. So the third term now, 21 minus k, and on the bottom you would have 2k, and that's all I need. So if they can get to that point, then that's fine. Now remembering that if I'm about to graph it, if I need to graph it, I do need to use x rather than k, because it won't graph it with a k. So what I've done here, I've graphed them both. And so I've graphed the left side and I've graphed the right side. Then all I need to do is find the intersection. Where they intersect could be the values of k. So analyse graph, and then down for the intersection. There's two of them, so there's one there and one there. So there's my first one, 1.4 and 7, and my second one, just do that all over again. Analyse graph, intersection, I start here and there. So I've got two solutions. K can equal either 1.4 or 3 for those solutions. So graphing the left side and the right side in anything can solve a multitude of problems. This method can be used to solve geometric sequences as well, where you have the third term of a geosequence is 8 and the ninth term is 72. Unfortunately, you do have to do a little bit of algebra with these ones, which shouldn't kill us. 8 equals u times r squared. I want that one. So, yeah, I'll see what I've done. I'll get rid of that last one. There we go. And then I need another one where 72 equals u times r to the 8. Now, do I have to do the 8 first? Whoops.
Just hit your square keypad.
Pardon?
Hit your square keypad.
Yeah, yeah.
And you can type it.
R
There you go.
to the 8. So now I've got both of those. Unfortunately, I do need to divide, which we don't like to do in studies, in high level or standard level. They can probably handle that a bit better. So I've got to divide the bottom one divided by the top one. So 72 divided by 8, I should get 9 equals, and then the u's disappear. So I get r to the 6. I need to do.
Did you explain it? That's correct. Yep.
Yep. R to the 6, and I need to put a u in there. U times. So
no, you don't need
equation,
u because the u's
the u's gone. Oh, yes, I know that.
Yeah. That's it.
So now I need to graph that one to find out what r could be. Now, what am I going to graph? I'm going to graph the right side equals x to the 6, and the left side equals 9, and see where they intersect. So I've got x to the 6 is this yellow one. What I did before, menu, analyze graph, intersection from there to there, and it gives that to me. And, I might move that along though, because I can't really see it all that well. Move that. That's better, because I need to see the other intersection. So menu, analyze graph, intersection, I need to find there. So there's two values that R could be for there to have an geometric sequence to work. And that is all I have. Thank you very much.
Thank you, Sandy, for that. So you've seen that, so you've actually, in the last screen, as people would know, you've actually got your graph has applications and graph the two functions. So you see function 6 being x to the 6th and your other function being 9, and use the intersection command. So a lot of people like yourself do that, or use the catalog and or the templates for those commands that you use through your part there. That's fantastic. So for the remaining part of the webinar, there's no questions at the moment in chat. I'll keep checking that. So I'd like to invite Peter Flynn to commence his section of the webinar. Thank you, Sandy.
Thank you.
There we are, Peter. We've got your screen.
Yes, thank you very much. So I'll concentrate on some trigonometry for 30 minutes or so, but before that I might just follow up with just a nice little sequences and series, well, the genesis of an activity. I think one of the things that I want to do here is, I don't know whether teachers really get a chance to be communicated to with regards to what are the new features in version 4.2. So I'm going to try and use trigonometry as a basis for illustrating some of these new features. So we've got a document here, and we might add a graphs page, and then we go to menu and then number 3, graph entry edit. What you'll find is that there is a new command or a new feature in version 4.2 which is called relation. So if you press number 2, and what we can do here obviously is we can graph relations. So for example, I might start off by graphing 3 straight lines with very carefully considered coefficients of x and y and a constant, just to show you the power of this particular new feature. So for example, we might type in 2x plus 5y equals 8, press enter, and we have that particular straight line displayed, and I'll hide the label. To bring up the entry line, again, it's a matter of pressing tab, and so you'll notice that it's now an opportunity for us to graph the second relation. Well, the first straight line, which is in the form ax plus by equals c, the coefficients of x and y were 2 and 5, and the constant was 8. So we've got 2, 5, 8. So for a matter of expediency, I will note to you that 2, 5 and 8 are terms in an arithmetic sequence with a first term of 2 and a common difference of 3. Let's do another one. Let's do 3 times x minus 4 times y equals negative 11, and press enter. Excellent. We have a second straight line appear. I'm pressing right click, it's control menu and then hide the label if you don't want the screen to end up being too cluttered. So the coefficients of x and y there are 3, negative 4 and negative 11. Arithmetic sequence, first term 3, common difference negative 7. Well, they intersect somewhere, so that looks not too bad so far. To bring up the entry line again, we can press tab, and this is our opportunity to enter our third straight line, as you can see by that 3 there. So far I've dealt with positive and negative integers for coefficients of x and y and the constant. Well, we might get a bit fancy now, and we might deal with coefficients of x and y and constants that are irrational. So we can do, I'm just going to use the computer keyboard here. You can type in pi like that, and it will be recognized as pi. So pi times x plus, and then open a bracket, pi plus 2 times y. equals pi plus 4, and then press. So, well, before I press enter, the coefficients of x and y and the constant, well, they're in arithmetic sequence as well. The first term is pi, and the common difference is 2. Now, I would do this far more differently with students. I would set it up as a guessing game where I would ask the students to give me a coefficient of x and a coefficient of y, and then what I would do is I would compute in my head what the constant should be so that we get an arithmetic sequence between the coefficient of x, the coefficient of y, and the constant. And what happens each time is you get this nice set of lines, and they all meet at the same point. And you can really pique the students' interest by playing this game, and they'll try and be smarty bums, and they'll move from positive integers to negative integers. They'll go to fractions, they'll go to decimals. Often when I've done this, I've mentioned, well, okay, we've done it for rationals, why don't we do it for irrationals? So it's also good to mention this from the point of view of number systems as well. So what's going on here? Well, we might as well find the coordinates of that point of intersection. So if we press menu, you can go to analyze graph and do it, but I'll go to geometry number 8. I'll then press number 1 for points and lines, and then number 3 for intersection points. And then all you need to do is click on one of the graphs, and then click on the another one of the graphs, and then I've just pressed escape there to get us out of that. And we get this nice result here that x equals -1 and y equals 2. And so after discussions with the students, we can come up with a conjecture, and the conjecture being that if you've got the coefficients of x and y and the constant in arithmetic sequence in an equation of the form ax plus by equals c, then those lines will all meet at a point, and they meet at the point x equals -1 and y equals 2. And so this is a nice learning trajectory, because we can start in a graphical representation, and we're in a non-CAS environment at the moment. So then what we could do is we could go to the whiteboard and we could say, well, can we illustrate why this is happening? Why do all these lines go through x equals -1 and y equals 2? So if I insert a notes page and I say, now this is not in a math box, so this is not active. And you'll also note that I won't be using the multiplication symbol. So we've got ax plus a plus d y equals a plus 2d. And I would then challenge the students to see if they can reason the fact that x equals -1 and y equals 2. Now, what some students will do is they'll just do a substitution. I've done this with teachers before, and teachers sometimes have been quite puzzled by this approach of equating coefficients, because if you look at the left-hand side, you've got ax plus ay plus dy equals a plus 2d. So in other words, you've got yd can be equated to 2d. In other words, y equals 2. And then what you can do is you can substitute y equals 2 into this equation, and then through some reasonably straightforward algebraic manipulation, it collapses to ax equals a plus 2d minus 2a minus 2d. The 2d's cancel. A minus 2a is -a, so ax equals -a, and assuming that a is non-zero, therefore you get x equals -1. And that is a result in 2 dimensions, and it can be generalized through to n dimensions actually, so that you can do this with 3 equations and 3 unknowns. And what happens in that instance is you've got 3 planes, and the 3 planes meet in a line. That can be shown quite readily. And then if you've got some real boffins in your class, you can extend it to n dimensions, which is certainly non-trivial. But the other result that comes out of this, and this is one that I like, is because I am a very disorganized person, particularly back in my youth, and I would often turn up to class without a textbook. We'd be teaching simultaneous equations, and I'd say to myself, well, I need a system of equations where I know the solutions are integer solutions. What can I make up in my head? Well, from this result you've just seen, what we can do is we can solve a system of 2 equations in 2 unknowns, where in the first equation the coefficients of x and y and the constant are in arithmetic sequence, and the second equation you can have the coefficients of x and y and the constant in a different arithmetic sequence. We know that we're going to get x equals -1 and y equals 2. And so we can illustrate this on a case-by-case basis in the notes application by using a math box, and also by using the solving of system of linear equations command that Sandi showed. So to insert a math box, we can press Control M, and that gives us a math box. You may have heard me say this before. I very rarely do any calculations with Inspire in the calculator application. I always use the notes application, and a strength for this will become apparent just in a moment. So inside this math box, if I press Menu and then I go to number 6, Calculations, and then number 3, Algebra, I just did what Sandi did, so we just undo that. Menu, Calculations, Algebra. Number 2 is Solve System of Linear Equations, and so we get a dialog box that comes up. There's no need to edit this. We've got, we're going to get 2 equations and our variables are x and y. So if we press on OK, and we get our template here. So then I would invite the students, well, come on, give us a couple of equations that follow that arithmetic sequence rule and we'll see what happens. So you might get one bright spark that says, well, what about x plus 4y equals 7 and 30x plus 22y equals 14. So just looking at that, 1, 4, 7, 30, 22, 14, that looks all right. So the prediction, you shouldn't do this, but the prediction should be x equals -1 and y equals 2. The solution should come out as a list, so you might need to mention that to students. So the great thing about the math box is we can go in and we can say, well, all right, why don't we change this to 40 and then change this to, well, why don't we make this 21? It's always dangerous doing this off the top of your head because you'll make boo-boos. So 40, 21 and 2, so it looks as though the common difference is -19 by my crappy arithmetic. There we go. So you can use that as a case generator by constantly editing that math box. And so that's a lovely result. And it's a good application of sequences and series. And it's an amalgamation of solving simultaneous equations and sequences and series. So it's marrying up a couple of topics from the course, which is a good idea. You may have seen me do this in the past. I won't do it tonight, but some really interesting results occur when the coefficients of x and y and the constant of both equations form a Fibonacci sequence, and from different parts of the Fibonacci sequence. And also you might see some interesting results occur if you've got your coefficients of x and y and constants in geometric sequence as well. But I might move on and have a little bit of a look at trig, and I'll look at it in the guise, really. The lens I want to use here is version 4.2, and to give you guys online a chance to get a taste for some of the new features, some of which you may say, yeah, I'm going to use that. Some of which you might say, well, it's good to know, but I've got my own preferred way of doing things, and of course that's all fine. So what we're going to do now is just to illustrate, again, graphing relations, but graphing inequalities. So just to show you that this power of graphing inequalities has widened in 4.2 in comparison to 4.0. So if I insert a new problem, what I always want to do here is if I want to start something new, I'll insert a new problem. And what that's doing, it's putting up a wall between problem 1, which is where I did the arithmetic sequence activity, and problem 2, which is where I'm now going to graph a couple of inequalities. So I'm going to add a graphs page, and then what happens is you get your function entry line automatically appears. To change that to the relation entry line, pardon me, you press menu, then 3 for graph entry edit, number 2 for relation, and let's see what sort of things we can do. Well, if we type in, for example, x minus sine y is greater than or equal to a half, so control equals, down to paste in that greater than or equal sign, and then control divided by for the symbols template. So we want here, so it's x minus sine y greater than or equal to a half. Do we get a required region? Yes, we do. So that's something that you could not have done in this way with previous operating systems. If I insert another graphs page and I go to the relation entry line again, another thing that you couldn't do before, which you can do now, is you can do something like x squared plus y squared. Let's do it, say, greater than, no, let's do less than or equal to. So control equals less than or equal to 1. And so I think in teaching what you want to do is if you're pressing buttons up on the board there and the students are watching, before enter is pressed, you might want to say, well, what do you think we're going to see? So hopefully we might see this. We might see a circle with that shaded area. So that's the region represented by that particular inequality. So you can do this with less than or equal to, less than, equals, greater than or equal to, or greater than. So let's move away from that now, and we'll show you another new feature. And what you can do now is you can generate sliders in the notes application. So that might be useful from the point of view of taking away some clutter from a graph screen and dumping the sliders actually in a notes application. And it might mean that you give the students a neater, more uncluttered representation of what you want to show them. So if we insert a new problem, so now we want to add a notes page, so we press number 6. So notice that 3.1, that's page 1 of problem 3. So I've put up a wall between problem 2 and problem 1. And just for exam purposes, I think that students, each new question they attempt in an IB exam, paper 2, paper 3, in the case of higher level, or in a VCE exam, each new question in a Inspire active exam, students should start with a new problem. That will get rid of all issues relating to stored variables and unexpected outputs, and then a kerfuffle occurring with them in the exam. So I've got a notes page opened up here, and so what we'll do is we'll insert a math box. So that's Control M, and what we might do here is we might use the assign command, which is obtained by pressing Control and then the symbols template. The assign command there, that's :equals. That is actually a fair dinkum riggy-dig CAS command. Define actually isn't, but define does the same thing as assign. My advice is if you've got a class of sort of battlers, I'd probably stick to define, because the battlers can often type in f of x equals, and that's not assigning the function. If you've got a class where most of them are high flyers, I would use the assign command. So what we're going to do is we're going to type in f of x and then Control symbols template to get the assign command, and then we'll type in a multiplied by sine x, and we'll press enter. So what we have is we have f of x is defined by that function, and we've got a variable or parameter, a variable constant. I wouldn't say that to the students, where you can vary the value of a and it's going to change the amplitude of that graph. Now what's happened here is we've ended up inside another math box. Now to insert a slider, you should not be in a math box. So what I'm going to do is I'm going to go one arrow to the right and then backspace twice, and I'm going to delete that math box. And now if I press menu, and then if I want to insert a slider, I'm saying to myself, well, hopefully I'll press 3 for insert, and I'm comforted by the fact that I see number 5, slider. And the slider dialog box appears. So we want A. I'm happy with a starting value of 1. Minimum, maximum can be fine. Step size is 1. I'm just tabbing through these fields. Then we can also minimize it, and we can press OK. And there's our slider. We have a slider in the notes application. What we can do now is we can go up and click inside our first math box, and then if we press Control menu, here is a new feature in 4.2. It's landed on this command graph. So what we can do is we can get a graph with our value of A appearing on the right hand side of the screen. So if I press 2 or enter, there we have our graph, and we can change the window as is needed. But what we can do to, well, I think for students on a split page with 2 applications, it's important to note that Control Tab allows you to toggle between applications on the same page. You can tell now that the Notes application is ignited because we've got the bold border. So I go in here and I start clicking the values of, changing the values of A, and then we can talk about the usual things that we talk about in this instance. So you could have this set up in a far more elaborate way. You can also change it so that there's more room devoted to the graph than the notes page. What is quite interesting I see there is that the assign command has changed to define. Now I don't know why that has happened, but anyway it has. And you could strengthen this. You could have a times sine bx plus c. You could have sliders for a, b and c here. And you can, it means that your graph is a screen is essentially uncluttered, and that the changing of the parameters can occur in an environment outside the graph. So I thought that that might be useful to you in your teaching. Another feature of 4.2 that I would like to show in the guise of trigonometry is, and I think Sandi hit upon this when she was graphing a sequence. She had 1 plus 2 times n minus 1. Now, yes, the n should have been an x, but what happened is that a message came up saying, do you want a slider for n? And this is a great new feature. We can generate sliders more expediently now because we get a prompt. So let's see how that works. So if we insert a problem, and what I want to do now is I want to add a graphs page number 2, and I do want to be on the function entry line. So if I type in a times, yes, we can get cos from trig, but I'm just typing in off the computer keyboard. A times cos x plus c. So what should happen when I press enter is I should get a prompt for 2 sliders, A and C. Now, we can uncheck if we want to do just one at a time. So let's press enter and just see what we get. Wow, look at this. It's asking us, do we want to create a slider for A and for C? And so I'm thinking, yeah, I think I do. So we'll press OK. And the default setting is that you get it with a slider bar, and these two, they seem to be sort of joined together. But what we can do is we can go inside the environment of the slider, and we can change the settings, and we can move the sliders around. So on a handheld, control menu does the trick. On a computer, it's right click. And the first thing I might want to do is I might want to minimize. So I'll press number 2. What that does is it seems to disattach, if that's such a word, the slider for A from the slider for C. And then we can also move it at the same time. Then we can come down and we can go inside where I think the environment is for the slider for C. We can press control menu and we can say, well, all right, I want to minimize this. And then if I just go, what I try to do here is I try to get the arrow just below one of the clicker buttons, press control menu, move, and then we can move this down the bottom. And then what we can do is we can change the values of A, of course, change the values of C. We get the usual effects occurring. What's interesting though is that I've set these up horizontally. Well, C has a vertical effect and so does A. It might be better if in the settings we change the style to vertical. If we can have our slider sort of orientated in a way that mirrors what we want the students to see, then I think that that might be a better idea. Of course, that's tricky when you're doing ax squared plus bx plus c and you want to change the value of b, because that's a mixture of horizontal and vertical translation. That actually goes along a defining parabola with equation y equals negative ax squared plus c. But if we go into settings here, and I'll just cut to the chase, just change that to vertical. So I think that there's some real subtleties there in the setting out of your sliders. If when they change the values of A and C, they see something happening in the vertical direction. Well, you might as well have the sliders oriented vertically. That would be my suggestion. Now, I'm running out of time a little bit, so I'll do this next little demonstration in an unrushed fashion and see where we end up. So I'm going to insert another problem, and I'm going to add a notes page. And what I want to illustrate here, I don't think what I'm going to illustrate students should do in an exam. Well, not all of it, but I think there are parts of what I'm about to show with regards to window settings that I think students could use in an exam. And I think that there are some interesting points here for teaching and learning with regards to window settings. So I'm going to give you the full palaver, and I would like you to take out little elements of my full palaver. So what we're going to do is we're going to solve a trig equation graphically, and the trig equation is solve 6 sine x plus 5 equals 7.5, and we're going to solve that for x values between negative pi and pi. So I'm going to set up 6 math boxes, and you're going to think to yourself, what on earth is he doing? But hopefully it will come together at the end. So Control M for the first math box, and I'm going to assign f of x. Actually, I'm going to do this as f1 of x just to prove that we can do it. And I'm going to say that that's 6 sine x plus 5. And then I'm going to use the domain constraint, control equals. Now here's a trick for you. Rather than going to the right and then down to get the width or the given key, in other words, we don't want students going da-da-da-da-da. All you need to do is go 1 to the left, and it takes you straight there. That saves a few milliseconds in the exam. And I'm going to come up with a generalized domain, actually. I'm going to say that this is given x1 is less than or equal to x, and then less than or equal to x2, and then press enter. And then I'm going to get the right-hand side of the equation assigned. So I'm going to assign f2 of x, and I'm going to assign that to be 7.5. So you can now, if you didn't get a handle upon the equation that I wanted to solve, you can see what it's going to be now. And I'm going to say that I want that given x1 is less than or equal to x, and then less than or equal to x2. Press enter. Now what I'm going to do is I'm going to set up a math box with x1. So x1, I'm going to assign that as negative pi. I'm now going to set up another math box, x2, and I'm going to assign that as pi. Now, with this template set up, you can go in and change your values for x1 and x2. So in other words, you can solve this and other equations in differing domains. The next thing I'm going to do is I'm going to assign x min, and I'm going to press menu, calculations, calculus, numerical function min, which is number 5, of f1 of x, comma x. Press enter. So that looks like negative pi on 2. And then I'm going to do the same for the function max. So I'm going to assign x max, menu, calculations, calculus, numerical function maximum, and then f1 of x with respect to x, and we get positive pi on 2. Okay, so what we can do now is we can add a graphs page. So we can insert a graphs page like so with our standard viewing window, and if we go up to F1 of X and press enter, well, that's not looking all that flash. I'll hide the label, press tab, go up, get our horizontal line, press enter. Well, that's not flash either. But we can be pretty smart here with the setting of the window, and rather than going into window settings, you can do this off the screen, and you can do it from stored variables from the notes page. So if I click on here, all I need to do is I can say, well, righto, I want that to be x1. Now, if you wanted to, you can show some leeway, and you can have x1 minus pi on 4 if you wanted to. So press tab, come up here, you can say, well, all right, I want f1 of x max, and then let's just add 2 for a bit of leeway. Press enter. I shouldn't have pressed enter because you could press tab and that'll take you down here. You can tab and toggle your way through here. So here I can type in x2. I can hide this label, and we're in a position now where we can find those 2 points of intersection. So menu, geometry, points and lines, intersection points. Click on one graph, click on the second graph, and there's the solutions. And with this template set up, if you're doing an exercise and you're demonstrating to students, and you've got a couple of similar questions, like this, really of the form, well, in this case it's it's AF of X plus C equals K, really, isn't it? You can use this, and I think there's also some good knowledge for the students as well in terms of that F of X max plus 2, you're promoting functional thought, which I think is really interesting as well. So it's now 7:59. I'll just insert a problem. Cosine rule and sine rule, really, I don't get too excited by them. In the blurb, it says that students should be cognizant of the mode for the exam. And so read the question carefully. This is all this obvious stuff. I must admit I've marked a few exams over the years in IB, and often in kinematics questions you will get students working in degrees rather than radians. That is a big no-no. But here's an interesting final thing. We add a geometry page. You want to draw a triangle, menu, actions, math draw, and then just freehand like so. Is it going to work? Yes, it works. Okay, so that's how you draw a triangle. And then what you can do is you can then go about doing some measurements. So you can measure, let's measure the length from there to there, and let's measure the length from there to there. We can also measure a couple of angles. So we'll measure the angle, and we'll measure that angle, that angle, that angle, and we'll also measure that angle, that angle, that angle, and then get out of it. So we've got that, and we've got that, and then we can move it up a little bit. And so what we can do is we can store this as C, and then we can store this as A, and we can store this as, if we go into our symbols template, we can store that, I think, as gamma. I'm doing this as a bit of a rush, so the chances of a mistake are very high. And then we can store this. So storing, it's just right-click or control menu. What's this? Is this the side opposite A? So what if we call this alpha? Is this looking all right, Rodney? Are you still awake?
Not a Great skills there, yes, I'm really enjoying this.
Stop lying, Rodney. So we've got this, and then what we can do is if we go to, got 2 minutes and then I'll finish. Control dock is not what I want. I want dock, so I'll press escape, go back to page 6.1, and then dock, page layout, select layout, layout 3, and then give this a notes application. Control M for a math box, then use the fraction template. So what have we got? We've got A on sine of alpha, and we want that in degrees. So if we press enter, we get a value, and then if this doesn't work, we'll just delete it from the tape. C on sine, open bracket, control, catalog, and then we want gamma, and then we want the degrees symbol. Oh, thank God for that.
Never in
so
doubt.
we'd expect these to be the same, and then we come up here, Rodney, and we throw it all around. You understand that we would also have a B on sine beta as well, and we can confirm that those ratios are the same. We can also determine that the longest side is opposite the largest angle, blah, 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 blah. Rodney, over to you.
Thank you, Peter. Thank you, Sandy. As you're aware, we all do things differently, and it's good watching these webinars and seeing how people do things and try things differently. So I'm thinking my 11 math speed later in the year might try a few things a little bit differently. So thank you for that again, Peter and Sandy. So just sharing my screen and have a look at that there. So just as a wrap up towards the end of the evening, so with the webinar that we've just seen, that we've also got other professional development events. So we've actually got a few events in Victoria, then we've actually got one on Friday actually, so here we are in services, and then conferences around Australia. So a lot of people present at conferences, so we're listing all the conferences here. We've got a AAMT Connect with Maths Day, then we've got the conferences, and a bit biased here, we've got the Queensland Association of Maths Teachers. I'm president, so we've got a conference in Cairns, so anyone in Victoria likes to come up to Queensland, so Cairns, a nice trip there. So, and we have Melissa Hourigan here, part of one of our trainers at TQ International Conference, so lovely photo there. And then, so obviously where people see these webinars have been recorded, so if participants like to actually visit education.ti.com, and if you're not sure, just type in Australia, this website comes up, and you'll see that there's a stack of information, as I said at the start, you know, updating your operating system. Then we've got the webinars here. If you select that, and the website will come up to the upcoming webinars. As you've seen tonight, we've got the IB with the TI-nspire. We've seen what Peter and Sandi have done, and then we've got one in March 29. So we've actually got IB with the calculus as well. Then in a few days' time, you'll see that the files and the webinar that's been recorded has been listed to the on-demand section, and you'll see that there's the webinar. You can download it and put it on external hard drive, and you've got the TNS files and PDFs. So, but don't forget, at the conclusion of this webinar, please complete the survey form, sign up for the newsletter. So just click one of the buttons, and you'll receive the newsletters advertising your future webinars and professional development opportunities. Also, you'll get that email in a couple of days with your contain your certificate link. And take care, and we look forward to your participation in future webinars. Bye for now. Thank you, Peter and Sandi.